Hi, in part two, we will discuss about bolt and then we will move on to type of connections. And then later on, we will take up how the connections we can formulate using different softwares. So, bolt generally will have a head, shank area, and thread, and nut, obviously. So, where we'll have a thread for using nut, so we will call it as a thread length. And the shank area, we will call it as a grip length. And total length we call it as the nominal length. The only important thing here we should know is like thread and shank area, because threaded area, if you see, there will be a loss in area compared to the shank. So generally when you put a bolt for any connection, so it may be thread or shank. So based on how much length of the thread and whether the bearing is on shank area or thread area, we need to understand. So generally we have to go considering the bolt in a threaded reason, but like code gives you value for both threaded and non-threaded part. So here you can see threaded condition. So I'll make it a little bit bigger. Yeah. So here in threaded condition, yeah, here you can see the value for, let's say if I take a 3 by 4 bolt, which is generally used, so it may be around 11.9. Okay, and the same for non-threaded part. If the load transfer happening in non-threaded part, so it is 15. So generally when we are designing bolt, we go with considering threaded part. So we are on a very conservative side, because sometimes the thread may be in the load bearing area. So I'll just show you how it will be in Lincoln. So this is just a shear tab connection. Here if you go, I'll just show you how it will varies. Here I'll select all things, and here I'll select N, so which is threaded area. So the load transfer is happening with threaded area. So here if you go and check for the capacity bolt, okay, single bolt capacity is 11.9. So this same as what is described in our code also. Yeah, here you can see it is 11.9. Same thing is showing here. And when I change it to X, so again if you go back and check for a single bolt capacity, yeah, so it becomes 14.9. Okay, so when it is in shank area, if the load transfer is happening in shank area, then the capacity is more. Or and if it is what we call, if it is happening in threaded part, then it is less bolt capacity. So you will need to have a more bolt, or you need to increase the size of the bolt if it is unable to carry load. So the ratio, just for understanding, we'll calculate what is the ratio of the load. So it is 11.9 divided by 15. So it is around 0.79. Okay. So the difference between them is around you can say around 20% for threaded to non-threaded part. Okay, so there will be a consideration which we have to take care of, and we have to be very careful with our consideration. So I suggest to better always go with the threaded condition as n, or which is in threaded part. Okay, which is in a reduction of area of the bolt. And then next we'll type of bolt. Generally, as per American standard, we'll have A325 and A490 bolt. And bolt tightening. And next is bolt tightening condition. One is snug tight, another one is pretension, and another one is a slip critical connection. So here you can refer my PPT, which will be in the description, so you can go through this. So snug tight is very easy to install, and it is cost effective as well, and it will be used in most of the location where we'll not have fatigue or very uh, reversible kind of loads. But slip critical will be provided where there is like earthquake load, or where there is what do we call, where there is a requirement for long slotted hole. So those kind of conditions we provide a slip critical connection. Here this is the more costliest one, because you'll have you need to prepare the area where the connection being installed. So you have to clean up that area so that it creates a friction between the two materials, friction. And when it comes to pretension bolt, in few cases we will need to have a pretension bolt. So, like as has it here, joint subjected to load reversal, subject to fatigue, subject to tensile fatigue. Okay, so there are these are all the conditions where pretension bolts will be required. So, pretension bolt in terms is nothing but like normal snug tighten snug tighten, and then after that there will be a definite pretension, definite turn you have to make so that required pretension will be achieved. So there will be separate different types of boards will be used, so that it shows what is the pretension level, so that you are not tightening is less or more. So as you can see here, once like for pretension bolt, just we have to do an snug tight, and then particular rotation you have to make so that it becomes a tension control bolt or pretension bolt. And as you can see here, slip critical connection, it is there, like it is load transfer is not happening with the bolt bearing. It happens through the bolt friction. So it will be tightened such a way that all the forces are happening through the friction. So when you have a long slotted hole, we have to provide a slip critical connection. And next thing is we should know what is the nominal hole dimension we have to give, considering the fabrication point of view for installation. Let's say you have like half-inch bolt, then hole dimension should be 9 by 16. So you should you should add 1 by 16 extra to your the bolt size, so that a bolt can be installed without any issue. So if we provide the same size of uh, bolt, then it inside is not possible for the fabricator or erector to install. So, and also there is a size are given in table J 3.3 if you are referring ASC, and if you are referring AS 800, you can also find a similar table. I'll just try to show you the table. Yeah, here you can see in section 10. So you can see here what is the clearance required, and what is the size we have to give. So you should have control over any of one standard, so that you can refer any of this standard easily. And also maximum spacing. Almost all the codes will have similarity, except there will be a few digit changes in size or dimension. And also as per AAC, minimum spacing preferred is 3D, or as per code it is 2 by 3 times the nominal diameter. So generally preferred we have to give 3D, 3 times the dimension. And also maximum space is also important criteria when it comes to HSS connection. This is the one I did a mistake in one of the job which I was doing. I'll just show you how it happened. Here you can see it is 12 times the thickness of a connecting pot, or okay, so nearest edge is 12 times the thickness of the connecting part. This for edge distance, and also this one 300 mm. So this is we have to keep it in mind when we are working with any of the HSS connections. So I'll just okay, yeah. So this was like plate. Okay, and then we had HSS member here. This is around I think 250 mm. So what was the issues, like we provided bolt here. So we provided bolt here and here. So as per code, we have to maintain minimum center to center like 300, like it should not exceed more than 300, and it should not be less than 3 times the D, so 300. So what happened is like we provided by mistake around 305 or 310. So here like we didn't had an option to provide bolt in this location. So like without knowing, we did like we provided 5 extra, so which is not as per standard. So in those kind of situation, you have to check and we have to make sure that the bolt what you're giving, it is within the range as prescribed particular code. So when you're referring any code, whether it is EN, BS, or ASC or IS 800, we have to one thing, like when you're doing any design, you have to go through those particular parts. Let's say if you're designing as per Indian standard, then you have to go to 800 and check what are the clauses applicable. So you have to read and understand, and you have to apply in that job. So it applies for all code. It's similar. So I'll show you one connection. Yeah, here. So as you can see, this is a simple shear tap connection. So I've done it in idea statica. So this is auto generated, so you don't have to not put much effort in this. So here you can change what is support and end condition, and you can change plate size, bolt, center to center distance. Okay, so here how it is. So one thing we have to make sure in connection is the beam center should not change. Let's say you are connecting, this is eccentric connection, let's say. So plate, we are providing only one side. Okay, the shear tap should not be to the center of column. The beam should be to the center of a column or a grid, because on structural model we cannot change for our connection. So we have to maintain like how the members are oriented in the structural drawing. As you can see here, like we have provided offset. So offset is like for shear connection or any kind of connection, like we have to give a minimum distance from column to the beam. So this is called offset. So this is there like which I'll going to explain next. So yeah, it is here. So called beam offset. So here we have any beam which you're giving, so you have to give minimum offset. So minimum offset as per like in India we follow 10 mm. So if it is like in as per ASC, it is the half inch. So that is 12 mm approximately. So this is offset and this is a plate length. And another reason being for providing offset is to allow a little bit of rotation during like when we are using a shear connection. And also, let's say if you are not providing offset, so the weld which you are going to place here, it may interference with your beam. So as you can see here, here, yeah, here when we provide a weld, I'll take a snapshot for better understanding. Okay, here let's say you are using a flat weld. Okay, so usually, like as I said in my earlier video, so always we have to make connection like weld should be symmetric. You cannot provide eccentric weld this side and you cannot avoid weld this side. Okay, so weld should be provided on both sides. So there's a weld. So if you are not providing this offset, what will happen? This offset what we are giving 10 mm gap from support to this B. Okay, so here what happens if it moves here? So this beam web, the beam web, it will going to hit, it will going to touch this triangular portion of weld. So with that, what happens? The web will start aligning here, and you cannot bolt and tighten it properly. So there will be disorientation in your uh, member alignment. So it is always good to, it is like it is required to provide a gap. Okay. And also here another like important parameter is like edge distance from bolt to edge from here, here. Just a second, I'll just take a snapshot of it. Yeah. Like important parameters like edge distance. Okay, this is vertical edge distance, and then this is horizontal edge distance to the plate. So preferred is 1.5 times the D. This is a preferred edge distance from center of bolt to any direction. As per code, it is 1.25 times the D, I think. So you can refer any of the code. So you understand. Yeah. So next we will move to, yeah, this is the edge distance as per American standard. So what is the minimum edge distance you have to maintain based on the diameter? So, but I would recommend you to use 1.5 times the D or 1.5 inch. So that you don't have to worry about edge distance all the time. So if you're changing your edge distance based on the bolt diameter, what happens is uh, like the drawing will be in the final stage of fabrication. That time the bolt engineer want to change the bolt size. So what happens here, like then you have a lot of changes will happen in your drawing. Instead of that, if you maintain 1.5 time 1.5 inch generally, so with that it solves most of issues. Okay, so that is one thing, so that you don't have to change the plate length. Let me explain one scenario. Okay, so this is a shear tab. Okay, this shear tab I will take it. Okay, so let's say I'll this edge distance I'll keep based on the diameter of the bolt. Let's say it comes me 1 inch for particular bolt size. Here also this also 1 inch. Okay, so when you are let's say if a structural engineer want to change a bolt size, he want to use a bigger so obviously the size of the hole will get changed, and also based on that your edge distance will also get changed. So earlier, let's say if I arrive using that, so let's say center to center it is 3 inch and outer it is 1 inch. So earlier it was 5 inch. So later if it becomes increased, it becomes 1.5 inch. So that time what happens, our size will become more for 1.5 existence. 3 inch 1.5. So now the plate size overall increased to 6 inch. So if you go to connection, let's say you have arrived all this depth and all you have done so much work in arriving at this depth. So later, like after if it increase, it may clash with your flange, or there may be so many issues. Like we are seeing a simple connection here, but in complicated connection, there may be so many other consideration which we have to take care. Let the flange is cut. So those time, what happens in those cases, you may have to change this cut has been made here as well. So it's better always to keep 1.5 inch 1.5 inch as a edge distance, so which take cares most of the cases generally. Yeah, this is how the force transfer happens, and we have to see the nature of connection, how it is getting connected, and how the force will get transferred. So it is not like that always there will be a shear in that bolt or tension in this bolt. It is how the connection is configured based on the force will transfer. Here, as you can see, mm, this bolts are there which here, so it will be a shear force. But here, where it is getting connected to the flange, for this it will be a tensile force. So you have to design this for bolt for shear, and this bolts for uh, tensile force. So similarly, this is a moment connection. A moment connection is nothing but where you are going to hold your flanges along with your web. But in shear connection, we will just hold web. So here, what happens when there is a moment? So we will have. I'll copy this and explain. This is one of like important concept which we have to know when we are doing moment connection, the shear connection. I'll explain that about moment connection, shear connection later stage as well. So this is just for understanding how the force transfer will happen. Let's say we have this beam. So obviously there is a moment here. So this is a flange. Yeah, moment, and when whatever the moment is there. Okay, this is our end condition. Okay, when it bends. Okay, when it bends, if it is a moment connection, so we will have a moment at the end. So that is the reason we are giving moment connection here to take care of this moment. Okay. So here, so how will you transfer this moment to forces? So finally, all this moment. So if you divide by this um, depth of a beam from center of top plane, so that gives us the lever arm. So when you divide moment by the lever arm length, okay, so that gives us a force. So it may be a compression or tension. So it depends on how where it is located. Let's say this flange, when it bends. Okay, so as we know, top flange will be in compression, and bottom flange will be in tension force. So when it is in let's say if this bolt in top, so it will have a shear force here and tensile force in this bolt. Okay, so we have to design these bolts for shear because it's pulling. This force is pulling this bolt, or creating providing a shear to this bolt, and simultaneously the bolts which are attached here to the support are having a tensile force. So you have to design this force for shear and this force for tensile force. Similarly, at the bottom, this force is pushing support. So obviously this is same like shear but in opposite direction. So both will be designed for shear. And this force you don't need actually, like it is in compression nature. So you don't have to design this bolt. So generally we provide what are the bolts that provide at top, we provide at the bottom, because there may be situation where we'll have a reversal of forces. So that time there may be a moment uh, which may get reversed. Okay, so generally it happens in seismic cases where your force will be getting changed, reversed here when there is a force in particular direction, and again when there is a change in direction, then it may be in opposite direction. So that time you cannot like provide bolt. So what are the connections at the top, same thing will be provided at the bottom. So this is one case, and this concept is very much important, and how the moment will be resolved and how it's applied on individual bolts. But if you're using in software, you don't have to worry about much. Like you have to take care of how the force will be given input in a software, and what output is giving, whether it is right or wrong, you should know. So you should know conceptually so that you can check whether the output provided by software is correct or not. Okay. So this is simple shear tap connection. So I'll talk about all this connection in detail in upcoming videos. Yeah, we'll move on to our next topic. Yeah, in same case, like in bracing connection, these bolts will be in shear. Yeah, shear lag is one of the effects like we'll experience in connections. So most of you already know what is shear lag. So there is a lag in shear transfer. So that is what we call it as a shear lag. As you can see by definition, this I got it from internet. So there is be a non-uniform distribution that occurs in a tension member adjacent to the connection. So if the uniform distribution of forces, it is the force is not transferring in a uniform way. So there will be additional stresses encountered. So those it will be called as a shear lag. So even in case of bracing connection, okay, we will have plate only one leg of uh, angle will be connected to the gusset. So other we are not connecting it. So what happens is when the force is applied, force applied to the entire cross section, but the force finally will get transferred only through one leg. So this is the lag which is happening. So this need to be taken care. I'll try to create one connection using bracing member so that we'll discuss about a few other topics in our next video, that part 3. And also we'll see in 3D how different configuration look like. Most important thing is what I suggest is instead of going through materials available online, so better stick to code and try to get information from the code, relevant code. So reference you can talk to client, or it will help in lot many ways. So we'll see in our next video about different type of moment connection, shear connection, and bracing connections, and also what are the different checks need to be done for all these kind of connections.